Hello everyone, today we're going to present our final project about Tesla. Tesla was founded in 2003 with the mission to accelerate the world's transition to sustainable transportation. Tesla currently produces two models, the Model S and the Model X, and Tesla will deliver its third model, the Model 3, in 2017. The forecast target for this project is to forecast the 5-year unit sales for all the three Tesla models from 2016 to 2020. We used base model and market share model to do all the analysis. Tesla Model S is a sedan which was delivered in 2012. The base model has a price about $70,000. Model X is a crossover SUV which was delivered in late 2015 with a price of $80,000 for base model. Tesla Model 3 is a crossover sedan which will be delivered in late 2017 and the base price will be about $35,000. So for the data collection part, we use both primary data collection and secondary data collection. We collect actual prices and actual unit sales for all the 9 models of electric vehicles that we choose from 2012 to 2015. All these data were collected from each brand's annual report. We also did a lot of research about the model's development trend and other forecast reports from other scholars, and also we collect information about market size and the coefficients of P and Q that we use in base model. For the base model, we determine the market size with the total sales from year 2012 to 2015. We also use the other electric vehicle forecast reports to determine the market size. For the coefficients of innovation and imitation, we first calculate the P and Q for Tesla S using post-launch base model. Then we use Tesla S coefficients and other electric vehicle coefficients to calculate the weighted average P and Q for Tesla Model X and Tesla Model 3. We also conduct sensitivity analysis with 3 different market size values. For the market share model, we assume that those 9 models of electric vehicles that we choose consist of the total market, and we use price as our only covariate in the model. Here's the key findings from our forecast for all the 3 Tesla models. As you can see that Tesla Model S have the most predict unit sales, while Tesla X and Tesla 3 have almost the same predict unit sales. For Tesla Model S, the market share model predicts better at the beginning because of the narrow market size. However, base model predicts more accurate in the next few years. And also, base model reflects a faster growth rate than the market share model does. Tesla Model X, you can see that the market share model generates a line that is almost a straight line, while the line that base model generates makes more sense. We think the reason is that the data for Tesla Model X in 2012 does not represent for a whole year, but only for 4 months, so that the market share model is not accurate and was affected to a high extent. For Tesla Model 3, we assume that the market size will be equal to 1.2 million. The coefficients P and Q are calculated by the weighted average from Tesla Model S, Ford Fusion, and other electric vehicles. And also the growth rate of Tesla 3 is lower than Tesla S and Tesla X. So under the assumption of the market size equal to 1.2 million, we can see that Tesla S has the most promising market growth, and also Tesla Model 3 will exceed Tesla X after 2020. So for the sensitivity analysis, we use three different market size equals to 0.7 million, 1.2 million, and 1.8 million. As you can see the graph that when market size is equal to 0.7 million, there is a slower growth rate in the late 2020, reflecting a conservative scenario. So we choose market size equal to 1.2 million to do the rest prediction. We can now say that our models are very accurate because there exist several limitations. The first one is data transformation limitation. So the actual unit sales data we collected were sales for each month, which were fluctuated and did not meet the requirement of increasing trend for best model. So we had to transform the data into annual unit sales, which might lead to an inaccurate best model. In addition, the electric vehicle Ford Fusion is at the end of its product life cycle, so that the calculated Q value was not accurate and might affect the Q values that we calculated for Tesla Model X and Tesla Model 3. Also, as we mentioned earlier, the data for Tesla Model X in 2015 was not complete, but also for 4 months, which is also inaccurate. And for market share model, we only consider 9 electric vehicles models that consist of the total market. However, there might be other new products in the next 5 years which will change the market size that we assume. Furthermore, the price and sales standard error are very high even after we calculated use the software in Excel. And finally, we have only used one covariate in our market share model, which is the price. And we think there should be other covariates that we need to consider, such as advertisement or like fuel price. However, we cannot get the advertisement data for every model that we choose, so we can only select the price as our only covariate. We think that if we can solve the limitations, that we should be able to get much better models for prediction and forecast. That's all for our presentations. Thank you very much.